Okay, here is part one of the fractions lesson. Whenever you're adding and subtracting fractions, you're going to have to look for a common denominator. Since this one already has one, you can go ahead and keep it and add or subtract the tops. So in this case, we're going to get 1. Okay, question 2, we have unlike denominators, so we're going to have to deal with that. One way to do that is we can start looking at multiples of 3 and start listing them in our brain. And we can look at multiples of 2 and start listing those in our brain. And the second we find a match, that is going to be our least common denominator. So what we'd like to do is change these two fractions so that they both have that same denominator, and then we can add them like problem 1. So how do we fix this problem? Because this one has a 3, what we can do is multiply it by 2 to change it into our 6. But we're not allowed to just change the denominator. We need to also compensate by changing the numerator, because when we multiply by 2 over 2, that is just a version of the number 1. Which means we will not actually be changing 5/3, we'll just be changing how it looks. We are actually unreducing the problem. So what are we going to wind up with? 6 that we wanted, and in the top, 10. Because remember, 10/6 is the same as 5/3 if you reduce it. So if you want to go from 5/3 to 10/6, you just unreduced it. How do you do that with a half? This time we got to multiply by 3, and our version of 1 is going to look a little different, but it's still 1. And we wind up with the 6 that we wanted, but the top is going to have to be a 3. And now we have, just like problem 1, same denominator. We can add the tops and keep the bottom. If you so choose, you can change this improper fraction to a mixed number by seeing how many times 6 goes into 13. That'd be 2 whole times. And what do you got left? 1 out of 6. Both of these answers are acceptable. Question 3. We also have an unlike denominator, which we need to take care of, and we also have to be careful. This is a subtraction problem. So at the end of the problem, make sure you subtract. What's the common denominator between 5 and 3? We're going to call it 15. And how do we change these fractions to 15s? This one is going to have to be multiplied by 3 over 3. And this one's going to have to be multiplied by 5 over 5. So if you go ahead and do that, you'll wind up with 12/15 minus 5/15. Better known as, don't add these like some people do. You subtract, and you are done. Number 4 is another unlike denominator problem. This time, our least common denominator is going to be 21. And we're back to addition. So we would like to turn the 7 into a 21. We can do that by multiplying by 3 and compensating the top also by 3. This time we can go by 7 and also by 7. So our first numerator is going to be 18 and our second numerator is going to be 14. Leaving us with an addition of 32 out of 21, which if you so choose you can rewrite as 1 and 11/21. Done. Okay, question number 5 is again an unlike denominator problem with one extra factor. We have a mixed number that we must take care of first. So in order to do this problem, what we need to do is take care of this fact that you can do 1 whole times the denominator plus the top. So you take the whole number times the denominator is 3, plus you have 1/3 left over, so you go 1 times 3 plus 1 is 4/3. Minus 2/5 doesn't need to be changed. So what's our common denominator? you'll find that it's 15 again. And how do we change these to be 15s? We will multiply by 5 over 5 and 3 over 3. And our new numerators are now going to be 20 and 6. So if you follow that this is a subtraction problem, you will get 14 out of 15 as a final answer. Good news for number 6, you'll see that now we are multiplying. When you are multiplying, you do not care what the denominators are. You don't have to get a least common denominator. You can simply multiply across the top and multiply across the bottom, and at the end of the problem you might have to reduce by a common factor, in this case 2, and you can get 2/3. If you so choose, you could have done this problem a slightly different way. Any factor in the top and any factor in the bottom in a multiplication could be reduced right off the bat. You could say 2 goes into 2 once, 2 goes into 4 twice, and then if you redid the problem you would have had 2 times 1, which is 2, over 3 times 1, which is 3, and that'll save you the reducing that you would have had to do at the end. Question number 7, back to multiplication. You do not have to worry about the denominator, so one way to do this problem is to multiply across the tops and multiply across the bottoms, and then you can see that they have a common factor of 20. You can reduce the problem. If you like to do it another way, you can start by reducing the problem before you multiply. That would look like this. 5 goes into 5 once and into 10 twice. You could say 4 and 6 have a common factor of 2, which goes in twice and 3 times. So if I did that at the beginning, I would have 1 times 2, which is 2, and 3 times 2, which is 6, and that would be a somewhat easier one to reduce. But either way you do the problem, you get the same answer. Okay, our final fraction problem for today has a multiplication, so again we don't worry about a common denominator, but we do have a mixed number we should take care of. And the technique is the whole number times the denominator and then add the numerator. So 1 times 3 is 3, plus 2, this is better known as 5/3, times 3/5, and we can now do the problem. One way to do this problem is multiply across the tops, multiply across the bottom, and then reduce later. But some of you might have noticed that we have factors on the diagonals that are common. So we could have reduced this problem from the get-go, and you'd see that everything was 1 times 1 over 1 times 1, better known as 1.